Hey guys, today we're going to look at 9.2. Today we're going to move from using vertex form to using standard form. Still a quadratic function, just going to look a little bit different, which means we have to graph it a little bit differently. Okay, so for the first one you got here, I've written down the standard form. Okay, standard form is y equals ax squared plus bx plus c. You'll notice it looks a little different than the form we've been using the past couple days. Okay, but we also need to know how to graph it in this form, and that's what we're going to look at today. Still going to be using your calculators quite a bit, so make sure you continue to have those handy for us. Okay, the way we find the axis of symmetry in the vertex when it's in standard form is there's actually going to be a formula that we're going to use. Okay, so to find the axis of symmetry, we're going to use the formula x equals negative b over 2a. Okay, remember, axis of symmetry is a vertical line, so it's always in the form x equals. Okay, where you get the b and the a from is from the original problem. Okay, the a is whatever number is with your x squared. The b is whatever number is with your x. Now, if your b is missing, which it will be a couple times, then it's just 0. Okay, if you don't have a piece, it's always considered a 0 if it is missing. Okay, once you find the axis of symmetry, then you can find the vertex by plugging it back in. Okay, so you just plug it back in and you'll find the rest of the vertex you need. Okay, so you're just going to plug the axis of symmetry into the function. Okay, and we'll look at how we do that here in our first example, but that is going to then give you the vertex you need. Then once you have the vertex, really we're going to do it in the calculator from there. Okay, so a big part of this will continue to be done in the calculator as well. So first example we have is just working on the new part of it here. So find the equation of the axis of symmetry and the vertex for each parabola. So first one I give you is f of x equals 3x squared minus 6x plus 5. Second one, y equals 2x squared minus 2x minus 6. Okay, so first thing it asks you to find is the axis of symmetry. Okay, so we again want to use that formula negative b over 2a. So for this problem, my b would be the negative 6. Okay, this is A, this is B, this is C. Okay, so negative a negative 6 will actually turn it to a positive, and then it'll be 2 times my A, which is 3. So you're going to end up getting 6 over 6, which tells me my axis of symmetry is x equals 1. Have to have the x equals, okay? It's a vertical line, so we must have that. Okay, then to find the vertex, okay, you're just going to take the 1 and you're going to plug it in for the x values. Okay, so what I'll end up getting is I'll get f of x, which we know is the same as y, 3, 1 squared, minus 6 times 1 plus 5. Okay, all you just have to do is just put that in the regular screen on the calculator, not the y equals screen. Okay, just the regular screen, and you'll end up getting 2. So that means that my vertex then would be 1, 2. Okay, the number you got here, the number you get here, combine together to give you your vertex. From there, you would put the function in the calculator, find the rest of the pieces, and we'll do that in our second example. Okay, so same thing here, axis of symmetry first. Okay, we'll use our negative b over 2a. In this case, our b is negative 2, so again, the two negatives will actually end up giving me a positive, and then 2 and a, that will give me 4. So I end up getting 1/2 in this case as my x. Okay, so then to find the vertex, I plug it back in. So 2, I do 1/2 squared minus 2 times the 1/2 minus 6. Okay, again, just put it in the regular screen, not the y equals screen. And for that one, you should end up with negative, you could do it in fraction or decimal. Either negative 6.5 or negative 13 over 2. Doesn't really matter on these if you give fraction or decimal as long as it ends. Okay, so that tells me my vertex then would be the 1/2 and the negative 13 over 2. Okay, so again, this formula gives you the x, plug it in, it'll give you the y. Then the rest of it we're going to do on our calculator. All right? So let's go ahead and look at that next part then. Alright, so again, you notice the standard form here. So first thing we have to do is we have to find the axis of symmetry in the vertex. Okay, so again, for the axis of symmetry, we're doing our negative b over 2a. So in this case, the b is 4, so it would be negative 4. 2 times my a is negative 1. Negative 4 over negative 2 will give me a positive 2. So the axis of symmetry is x equals 2. Okay, then I need to plug it back in. Okay, if you plug that one back in, you'll end up getting 2 again. Okay, so that tells me that my vertex is going to be 2, 2. Okay, so that means that I'm going to go to 2, 2 to get my first point. And then you can go ahead and put it in the calculator to get the other points that you need. Okay, when you put it in the calculator, okay, you'll go to 2, 2, use that as the vertex, and we'll want to do 2 on each side. So the other ones you should get are 1, 1, and 3, 1. And then you'll also end up getting negative 0, negative 2. And so then it'd be 4, negative 2. So your graph should end up looking something like this. Again, the rest of the points we just get by putting it in the y equals in the calculator like you have been doing so far in this chapter. All right, we'll do one more of these. I think this one on yours is incorrect. I think I put a 3x there. It should be a 6x, so please fix that on yours when you're looking through it. Okay, so again, we'll start off the same way. Get our x here, our negative b over 2a. So in this case, it would be negative 6, and then it'd be 2 times 3, which is also 6. So I end up with x equals negative 1 as my axis of symmetry. Plug that back in. And you'll end up getting the rest of the vertex, which also gives you a negative 1. Okay, so that means my vertex is going to be at negative 1, negative 1. Okay, from there, put it in the y equals in the calculator, go to your table, and we'll get the other points that we need. Okay, for this one, your next points on either side should be 0, 2, and negative 2, 2. And then you'll end up with 112, which ends up being kind of way up here at the top of the graph. And then we'll end up with the same thing on the other side, again, because they are mirror images of each other. Okay, so your graph would end up looking like that. So the only difference on those is finding the axis of symmetry and working with and finding the vertex. Just have to find those a little bit differently. Okay, one other way I'm going to show you how this can be used, just so you can kind of see how it applies to a real world problem. Just talk about this here real quick with you guys. Okay, you'll notice it says to find the height of an object above ground in feet, you use the function h equals negative 16t squared plus vt plus c. Okay, that's the object of anything being launched or thrown. If you were to, launch a rocket, how it goes up and comes back down, that's the shape of a parabola. Okay, if you were to throw a high baseball or hit a pop-up, it would go up and come down. Okay, you kind of get that parabola shape with all of that stuff. It tells you c is the initial height and v is the initial upward velocity. So those are the two numbers that we'll have to plug in. Okay, this one always stays this. This actually stands for gravity. Okay, the gravity that's pulling the ball back to Earth or the missile or the rocket or whatever you end up launching. Okay, so for example 3, it says Daniel kicks a soccer ball into the air with an initial upward velocity of 64 feet per second. The ball is 2 feet above the ground when it's kicked. How long will it take the ball to reach its maximum height? How high above the ground will the ball be? And what's the range of the function? We've actually worked with all these pieces. Now we're just putting them in the context of an actual problem. Okay, so you'll notice for part A, it asks you to write the function. Well, we're going to use this function. We just need to plug in the V and the C. Okay, so H will always be our height. Okay, in this case, height is being measured in feet. Again, the negative 16's gravity. T stands for time, okay, for this problem. Okay, so it tells us that the velocity was 64 feet per second. And it tells us it's initially 2 feet above ground. So probably had it in his hand and then dropped it and kicked it from there. Okay, so this would be the function that we're using. It asks us to draw a representation. Now, we don't actually have to put this in the calculator. We just want to get an idea of what would it look like. Okay, so our h now is our height. That is our y, because it's always y equals, now it's h equals. Okay, so this would be our height right here. And then this would be our time, because it replaced our x. So if you think about it, he's right here before any time. There's our soccer ball just a little bit above the ground. Okay, he's going to kick the soccer ball. It's going to go up, heat a peak, and then it's going to come somewhere back down to Earth. Okay, and again, what we're looking for then are those pieces. Okay, so part C says, how long will it take the ball to reach its maximum height? Now, maximum height is the same thing as the vertex. So essentially what we're going to try and find is the axis of symmetry and vertex, just like we did earlier today. Okay, so for C, we're going to do the same thing. We're going to still do our x equals negative b over 2a. So your b would be 64. Our a is negative 16. Simplify that and you will get 2. Okay, so that means the first part of our vertex is 2. That would be the time part of it. So basically it's saying it takes 2 seconds to get to its highest point, okay, when we're working with it. Okay, which is exactly what part C asks. So how long does it take? It takes 2 seconds. Okay, part D says, what is the maximum height? Well, to find the maximum height, plug your 2 back in. It just means find the rest of the vertex. Okay, so in this case, if I plug my 2 back in, okay, if you plug that in the calculator, you'll end up getting a height of 66. Okay, so that means the ball went 66 feet in the air at the 2-second mark. Okay, you have part E, which is the range. I'm not going to worry about that one right now. I just kind of wanted to show you how the axis of symmetry and the vertex can be used in time and height. And that's actually where it's used a lot. Okay, so just wanted to give you guys a chance for that. Okay, today's assignment is a book assignment. Okay, so make sure you get that done. Check the Google form. And then we are going to be rolling into a quiz here. So the next 2 days will be a review, and then we will have a quiz after that. Okay, so again, just basically over all our different graphing stuff that we've been working on. All right, have a great rest of your day.